Okay, we're back. All right, we're talking about drilling floor joists, but this is back on number structural integrity number 20. And while I was waiting to make this changeover, I remembered that sometimes we talk about trusses, sometimes we don't. All right, the truss that most of you are familiar with would be a roof truss like this here, right? Kind of looks like a W. Now, the trusses are very strong and they're used in quite a few places, commercial and residential. I know Feynman, this is what I heard. Feynman aren't too crazy about them in commercial buildings because the big ones can actually span a very long distance. But once they start to burn, it doesn't take much and the whole thing just collapses. So it can be a problem, but not our problem. All right, these are the metal plates that they just press on there back at the factory. I remember when I was a building inspector, um, I didn't inspect these things. I used to get a letter from an architect or an engineer with their stamp on it that the trusses that were being sent to the job were the trusses for that job. And that was enough for me. So this here would be a truss, uh, 2x4. These would be like the rafters to hold up the roof. Now, how does it apply to us? When you put your piping up in the attic, never notch, drill, don't do anything to these trusses, okay? If you start to drill these, you're going to be in a lot of trouble because it takes away the integrity really fast. They're only 2x4s. So what you do is you put a hanger up or whatever you have to do. Just don't drill it on notch it. All right. Other than putting a hanger up here or resting it, maybe going across here. That's about all you can do. Okay. Now the floor truss, which you don't see as often, kind of looks like this. And again, 2x4 construction, looking on edge like this here. And the bigger the gap between the two layers, the two levels, the further that it can go. So if you want to span like a whole garage, maybe the basement, you want to put a pool table down there, and you don't want to put a steel I-beam. Okay, you can put a truss floor. But again, whether it's a truss roof, where you're in the attic, or like floor joists going into the basement, don't drill them or cut them at all. Okay, that is it on trusses. Okay, number 21. We have protect ground and surface water. All discharge to ground surface water shall meet local, state, federal water quality discharge standards. I don't know if that really applies to us. We really don't put any water outside onto the ground. Well, the only time you might run into a problem is if you have condensate coming down from central air conditioning. Some of you guys that have run central air, you might run 3/4 PVC from the attic or wherever your unit's located down, and some inspectors won't let you take it outside and just drip it onto the ground. It's clean water, but sometimes they want it piped into the basement, into the drain like a clothes washer, so it'd be an indirect drain. So if I made a sketch of it, it'd look just like the clothes washer with one pipe inside the standpipe. The problem is for the 6-7 months when there's no condensate because it's not working, you might have to put a trap primer. That's that thing that lets a little water in and drips in. So you might have something like this. You might have a 1.5 inch pipe, standpipe, and on one side you have a 1/2 inch line coming in here from the or 3/4, whatever, and over here you might have um, a trap primer. Okay, so here's your warmer months over here. This would be like a 1/2 inch line, and then to cover the so this doesn't evaporate. Right, 6 months is a long time. Probably would evaporate. So you have a trap primer on the other side. That's about the only time I can think of where you might run into a situation where the inspector doesn't want you discharging onto the ground. Otherwise, everything we do either goes into a septic, um, about it. Septic or city sewer. Okay, number 20. Actually, that was number 21. 22. Piping and treatment of hazardous waste. Okay. First one that comes to mind is if you have, let's say, a science lab. Now, commercially, of course, there's certain processes I'm sure that are absolutely hazardous, and they have to neutralize. If it's an acid, they put alkaline, and they mix it uh, so that when it's done, it's neutral and it can safely go into the system. But what they want you to do is to tie it in the building. So if you had a wall like this, actually, this was a question on my license exam one time. You have city sewer like that, and we'll say that this is 10 feet from here, inside face, to here. And what I had to do, we'll say that this green one's going to be an acid line coming from our acid waste, was to run it outside, alongside the pipe. I got to go under it because you won't be able to see it. And I'd go 10 feet out, and then I could wire it in like that. So this would be 10 feet, we'll say right there. Okay, so once you're 10 feet out of the building, the code lets you tie this line back in once it's been properly neutralized. Okay? All right, that was number what? 20. Treatment of hazardous waste. Okay. All right, just a couple left here. Need for privacy. Okay, this is here, but this really applies to the building code, not to us, but it's here. So if you've been in a modern bathroom, there's always those little privacy shields between the urinals, but in an old bathroom, of course, there's not. I don't know how this applies to us at all, other than it's in the code, which means we're responsible. Okay, number 24, drinking fountain shall be installed in a safe, clean, and hazard-free area. Okay, that's obvious. But it cannot be in the restroom itself, right? Installation of a drinking fountain in a restroom that incorporates toilets or urinals is prohibited. It's got to be like outside the door, which it always is. Number 23, temporary construction trailers are exempt from the material provisions of this code. The water and sewer connections shall be the same materials as supplied by the trailer manufacturer. All right, I guess what they're saying is that I don't know why they just use temporary construction trailers. These are the ones that you see on big jobs. Sometimes they have multiple trailers, and they'll be there, till the job is done. And the code is a little flexible on how those are hooked up. Now, house trailers, if anybody here has done a job where people have been burned out, usually it's a fire. There are companies that will come in with a trailer and it's already all furnished. It's not bad. I've been in a few of them. They're pretty decent. And what they do is to run like flexible lines over to your septic system, and they'll somehow tie on to the water. I don't remember if they have a water heater inside. I never hooked one up, so I'm not sure about that water heater and so on. But what they do is use your own septic and or city sewer connections, right? And that unit will be there for however whatever arrangement you make with the inspector. We'll say 6 months till you can get a new house built. Okay, I'm sure there's some maximum time limit on it, but I think they're pretty generous about it, and they realize the owners are in a tough spot, and they're as far as like how far off the property line and all that, they kind of look the other way until you get the house done, and then the trailer leaves. And I remember as an inspector, there was one trailer that seemed to be making the rounds. And I remember I actually kind of negotiated one time. Somebody was looking for a trailer and asked me if I knew. I said, yeah. I said, there's one that's just about, the house is almost done. And I put them in touch with each other. And one trailer went from one site to another. It was actually not a rental. It was a very inexpensive, well-worn trailer. So you'll see them out there. But they're mentioning construction rather than residential. And I don't know why it's just construction. Okay, last one, materials and design. They mentioned that there's much more of this in the book, and I don't even know why they even give it much more than a paragraph like this. We're not really concerned about testing materials and all the rest of it. That's not our job. If you're a manufacturer and you want to have your and you think you've got something as good as PVC or better and it's less money to make, knock yourself out. Check with the state. They'll tell you the standards that have to be met before they will approve the product. And until that time, it cannot be used in the state of Massachusetts. All right, from what I gather, they're pretty fussy. Okay, but it really doesn't apply to us. We don't get involved in that end of the business. Okay, so that was number 26. And what I'd like to do is to go back to the definitions. The other night, we finished up with a branch vent. And I think that's where we stopped. Okay, the next one was a building. All right, it's interesting they even have that here. It says a structure used for the housing, shelter, enclosure, or support of persons, animals, or property. Okay, pretty general. I don't think we need to go any further with that. A building drain. Now, we've done the building drain so many times. And actually, I've got part of one up here. So this here, remember, this is still the building drain. And the building sewer is what begins 10 feet outside the wall, right? So the building sewer is this way. And also remember, the plumbing inspector, he looks at it like this. He doesn't see that. Of course he does, but he's not involved with it. He's got enough to do on the house side. All right, now where did this building drain begin? This is the end of it where it enters the system, right? It goes right here into the building sewer. The bottom of the stack, let's see what they say there. The lowest horizontal piping that extends from the base of the stack to a terminating point 10 feet outside the interface of the foundation wall. There it is, right there. All right, so we just happen to have the end of the system up on the wall, up on the board here. Okay. Now, on the next page, they mention a sanitary building drain and a storm building drain. Okay. The sanitary is like the pipe I'm erasing from a house. That's a sanitary drain. Now, a stormwater drain would be like, say, you tied all the drains together and from a commercial building or a residential building. Some cities, I don't know where, not around here, because all the cities around here are very old and they have combined systems. The sanitary and the storm, for us, are combined. Storm and sanitary. Okay? The reason is this. Over 100 years ago, back in the 1800s, when the plumbing was installed in Florida, the last thing on their mind was cleaning up the water and keeping it separate from the storm water. So as a result, any storm water that came off the roofs, especially some of you guys have seen this, the old 3-family houses always had this. It would come off the roof, down a downspout. The old ones were round, the new ones are kind of rectangular. And maybe 6 feet above the ground, it would switch over to cast iron so it wouldn't get banged up and go down and into the cellar and tie into the building drain in the basement. I think there's a trap on it where it tied in. Okay, that is okay because it's grandfathered. But let's say all that piping was taken out for some reason. You got to find another home for the water coming off the roof. I don't think the inspector's going to want you to put it back into the system. Okay? Because when the system was built back in the 1800s, it was a combined system because they didn't have to treat it. So who cares if it was fresh water and sewage? So what happened was 50, 60 years ago, whenever the treatment plant opened up, I always thought it was in the 50s, but I think it was later. Now we got a problem because the storm water is mixing with the sanitary water. And I remember when I used to take the high school kids on a tour down there back in the 80s. They used to get 15 to 20 million gallons per day. Okay, that was typical. And I remember there was a time where they used to publish the amount of water being pumped out of the Watuppa Pond. And for some reason, I used to look at it once in a while, and it was all the same number. So when the guy told us that, I said, well, how can that be? You're only pumping, the city's pumping about the same amount of water out of Watuppa Pond. He said there's so many breaks in the line. There's like uh, springs and streams that are entering the piping that's underground. As a result, it's roughly the same coming out down near the bay as is being pumped out of Watuppa Pond. Okay, but they could handle this, right? Goes into tanks. I'm not going to draw it up here, but just picture everything goes into the tanks and it all settles out. It looks like a cone. It goes down to the bottom and have these giant screws that take all the solid stuff out. And the water spills over. It keeps on spilling over, and it goes into another set of tanks. So they have a name for it where there's the primary, then the secondaries. Then there's some systems that have a third time they do that. Well, the Florida system cleans it up quite a bit. And the number I remember him telling me was about 87% cleaner when they put it back into the bay. And before it goes back into Mount Hope Bay, they have these like a maze, a canal, and they dump a ton of like a Clorox bleach kind of material, liquid into it to kill any bacteria before it goes into the bay. Now, here's the problem. This is all well and good, but when we have a downpour, some of you guys might remember this, or I don't know if it still happens. The shellfish beds get closed for 2-3 days at a time because the treatment plant cannot handle 50 million gallons. Right? So what they used to do is because it was just too much for the equipment, to just open the floodgates and let it rip into the bay. And they'd throw some Clorox or whatever on it as it went by, but it wasn't very good. And as a result, the shellfish beds were closed for a set amount of time, 2-3 days, if I remember right. Okay. And now they have those tunnels that actually go underneath the city. I'm sure you all remember hearing about that. And the tunnels are like, I think, 10 feet in diameter. So it's a gigantic storage tank, a couple miles long. And we did the math on it once, and it held like something like this, like 15 to 20 million gallons. It was a lot of water. So what happens if we have a downpour? Instead of the water going into the bay, it goes into this tunnel. And then when the storm's over, they can process the water over a much longer period of time, when they're not being pressed because of the storm. And that way the bay doesn't get trashed like it used to. Okay, so that was just, like I said, only because I took the kids there on a field trip several times that I knew about this here. Okay, let's get back to, that was number, oh, wait a minute, excuse me, it was the definition. That was sanitary and storm. So what you need to take away from this is the storm is fresh water, right? That's like downspout water off the street, things like that. Of course, it's not drinking water, but it's water. It's not sanitary. It's not sewage. And because we're a very old city, Fall River, we have an old system, a combined system. There's only one. I've heard some cities like have two, one for storm, one for sanitary. So one would like go right into the bay, and the other would the storm, and then the other one would go into a treatment. Building sewer. We talked about that. That was the one that begins 10 feet outside the wall and goes to the city sewer. The exception would be septic tank. I consider the septic tank the building sewer. So you go 10 feet outside the wall, and usually those of you who've done septic tanks know that 10 feet's a bit far. It's usually closer than that. But we'll say the septic tank itself is like the building sewer. Okay? So let's leave that one right there. Okay, the next one we have is the building subdrain. Now this one, I'm quite sure I haven't talked about it this year, so let's take a look at it. First of all, let's read it, and then I'll make a quick sketch. Portion of a drainage system that cannot drain its discharge into a building sewer via the force of gravity. Okay, that's actually written pretty well. So if it can't drain by gravity, it's a building subdrain. So let's say that you have a system goes out the wall like that. Okay, and we're going to draw the floor in, which we usually don't, but I need it because I got to put a sewage ejector in. All right, so what we're going to do is to put a tank in the floor because I want to put a bathroom in the basement, but I can't because it drains 4 feet up in the air. So somebody gets lucky and cuts this can into the floor, right? And then you're going to put your water closet. Toilet's going to be right here. There'll be a wall right here, and this will come off like that and go over and ran out of room. That's okay. And out it goes. Okay, so this will be a 2-inch line. This is a 2-inch line, and this is a wet vent, right? Because it ties in like that. So those of you who've done basement baths, I think everybody's done a basement bath that I've talked to have all done the same thing. You do a wet vent. Wet vent. This is jumping over this pipe. Okay, so it gets in here, and sewage ejector is here. Pump comes right through the top of the tank, up, over, and in. This here is a check valve, vertical check. It's 90, 45, and a Y. Okay? So what they're saying is everything below this level here, right here, the building subdrain. Okay, so everything down here, because nothing in here can drain by gravity. It's got to be lifted mechanically up and out. Okay, so that's quickly what a building subdrain is. All right, they got building subdrain sanitary. All right, that's this one. And then they got storm. I guess that could be a sump pump, right? Because you're pumping clear water. Excluding sewage. All right, I'd say that would be a sump pump. All right, but we'll just leave that one alone. All right, a circuit vent. Now, this here is more for tier 2. I believe we've already done this. We did circuit, and I don't want to do it now because that's a class in itself. That's like probably an hour just on, or at least a half hour just on circuit vent. But this is when you have 2 or more floor-mounted fixtures, right? And you have a vent between them, right? So they'd be strung out in a row. Like usually we draw about 6 of them, and the vent is between the last 2, 5 and 6. You can go up to 8 floor-mounted fixtures like that. Not wall-hung. It's got to be floor-mounted. All right, so just kind of make note of it. And a combination fixture. You put here kitchen sink, 2-bowl kitchen sink, 3-bowl kitchen sink. It's a fixture that combines multiple compartments into one unit. Okay. Now the next one is a very specialized system that I heard about in night school many years ago, many years ago. I have never worked on it. I suspect you might see this, and you guys work maybe in Boston. I think it's called a Sovent system. It's got a very fancy T with a passageway for the air, and you can actually get by without a vent. But this one will have to be drawn by an engineer or an architect and approved. All right, this is something we might install, but it's nothing we would be designing. All right, so that would be the combination waste and vent system. Okay, and the last one is a common vent. I believe another name for that is a dual vent. And you'll find this at the end of the code book where they have all the sketches. All right, where you have there's probably at least 10 pages of sketches, and they have a whole page of common vents. And I'll show you the most common of the common vents. And I'm sure most of you have done this. Okay, this would be like back-to-back labs, men's room, ladies' room. Could be just a private home where you have two labs back-to-back, right? Master bath, kids' bath on the other side. Something like this. So this fixture fitting, fitting would be a TY, like that. Okay? Double TY, double TY. What size line by code? Your boss might have other plans, but in fact, they will. Nobody's going to be doing this, but this is what code calls for. Don't forget, this is the book solution. It's not real life. Okay, so the 1.5 inches you might do, but this I'm sure you're not doing. That's what it looks like. Now, the other day, I think it was last week, there was a sketch. Oh, one of the movies, one of the videos you guys watched, and I think it was This Old House. If you remember, they did this. Okay, remember that? This was a Y right here, a double Y. Let me make it a little clearer. Can't do that. That's a 3/4 S trap. What that is this here, right? It's like it's one of the illegal traps. Okay, so be aware of it. Don't do this. All right, especially if it's being inspected. That's got to be a double TY. Right, it just kicks a little bit, and that's an example of a common vent. I'll tell you what. This will be the last thing for this this video. Let's say you have. I'm going to make this back into a TY. Once in a while, you bump into a house where you might have a step up one level to another, and you have back-to-back bathrooms. So you wouldn't have a TY because one TY on the other come through the wall would be like at 10 inches. It's kind of too low. So how high can I go before I would have to vent the lower one? Okay, the answer is 10 inches. So what I would do here is to put another TY right here. Okay, now this here is 10 inches. Oops. All right, that's max. Okay, 10 inches between these two here. Another thing you might run into is the space here is too much. You can get a street. I don't know if anybody, if all of you have seen it, but you can get a street TY. All right, so this TY goes into this one and saves you 3/4 inch or a little more. Okay, but 10-inch maximum between these two levels. It's another example of a common vent. Go to that page if you have a book, or you want to look it up online, and they've got a whole lot of common vents, but those are just two of them. Okay, all right, that is it. I'm going to do a little bit of math, but that's it on the definitions for right now. Okay, I will see you in a minute.